Now this is a one-to-one representation of what we're seeing from BeyondATC into the sim. Hello and welcome to a very special BeyondATC video. Today, instead of our normal flights, we're going to be showing off some of the progress we've been making on the program over the last couple months. And since our last video, the last video had us showing the rewrite of BeyondATC. Now the reason that we did this rewrite is because we decided to be our own traffic injector. We feel this is the only real way to control the ATC experience from the top to bottom. That means that we had to rewrite everything. Now, in the last video that I showed, the one to Amsterdam, we took a flight using that new rebuilt model that was showing how the actual ATC side of it is going to work. Today we're going to show the traffic injection side of it. So this isn't going to be using BeyondATC directly. This is going to be showing our kind of developer debug environment to kind of show how this whole process is working. So it'll be a little bit more technical of a video, not normally what I show, but I think it'd be some really good insight onto everything we've been working on since it's been a little quiet lately. But rest assured, we're hard at work on all of these cool new features, and I think it's really exciting, and I can't wait to show it to you. So let's get into it. So here we have the BeyondATC debug environment. This is a representation of the 3D engine that's running behind BeyondATC. When you see the user interface from the flights I was doing in the past couple videos, behind that user interface is actually a full 3D engine. Now the thing that makes this whole thing work, when most people hear a 3D engine, the first thing they think is that must be very expensive. What about my precious FPS? Well, we're not actually rendering anything. The thing that's most costly about a 3D engine is the polygons, the textures, the shaders. We're not using any of that. You already have all that in the sim, so we don't need to recreate that. All we're using the 3D engine for is to do calculations of spacing and figure out where things are in relation to each other. So here we're looking at a custom version of it where we're looking at what BeyondATC sees behind the actual program. So it's kind of funny to think that you're looking at this really basic UI, with just like buttons and drop-down menus, but behind that is actually a full simulation of the 3D space that's happening. We built this because in order to make the injector work, we need to know where all the planes are at any given moment. We're controlling them directly. As there's multiple ways to actually control the aircraft in the sim, all the ones on the market right now hand off the traffic into the sim, into Microsoft Flight Simulator, and say, here's the plane I want at this position at this time. I want it to go do this, and the sim takes over. This is what causes the massive FPS drop when you run a program that is injecting traffic. What we're doing is doing custom control of that aircraft. That means that this is much more FPS friendly, but the downside, of course, is that we have to control where the airplane is at any given moment. That becomes very, very challenging. And the first thing we need to do is get the actual airport data. So here I'll load LAX, and this is coming straight from the sim. This is loading it from the scenery file that you have on your computer. So if two different people have two different scenery files, BeyondATC will look at whatever scenery file you have and load the airport according to that. That means if the taxiways are wrong on the scenery file that you have, it's not great that it's not giving the correct taxiways according to charts, but it will give the same taxiways that you see in the sim, which to us is the most important thing. So whatever your scenery file looks like on your computer, that's what BeyondATC will see. So this is being loaded from LAX on my computer here. And what we're doing is getting a bunch of points and connections and then recreating them in our 3D world in order to represent the airport. So this was the first step, and just getting this airport to load was a huge amount of work. So now that we have the airport, the next step is that we have to make outgoing paths to the runways. And the reason that we do this is because we need to create common paths that allow planes to follow each other down specific routes. There's no way to know that this particular taxiway is outgoing and this particular taxiway is incoming, right? Because yes, we can custom code that for a specific airport, for 10, for 100, but there's 40,000 plus airports in Microsoft Flight Simulator. So there's no way we can do all that by hand. What we need to do is create a rule set for how every single airport will work by default, and then later on we can go add custom standard operating procedures for that airport if that's something that players want for that specific airport. So in order to do that, we generate a plane at every single gate and we move that plane out to where it's trying to go. So let's say in this case we generate a plane right here at this gate, and we send it out to 24 left, which is the outgoing runways in this case. We have 25 right and 24 left are the two outgoing runways. And these aren't real planes. These are like fake planes that are used to cache data about how we want to create our paths. So we generate one here, send it out, and then store its path. Then we go over next gate, do the same thing. The next gate, do the same thing. And we're going to start to get paths that overlap each other quite a bit. There's going to be a common element of that path that once we store them, we can go through all the paths that we stored, find the overlapping points, and figure out what's the most common path that airplanes use to get to the runway. Think of it like a heat map, right? So the more stuff goes over that spot, the more likely it is that we reassign that spot to the outgoing path. And that gives us these common paths, which is what you're seeing in green here. So the green represents what the airplanes want to take the most to get to their destination. If it's white, they'll basically try and avoid it if possible. So incoming aircraft, aka aircraft that are landing and coming off the runway, they try and avoid the green. Whereas aircraft that are outgoing, aka going from the gate to the runway, they try and take the green path. So let's show that off by spawning just one aircraft. Remember, this is only in our debug environment. I'll show it in the sim in a second. And this is our airplane. This is our injector right here, working with our own data. So we built all this. None of this is being handled by Microsoft Flight Simulator. This is completely BeyondATC doing all of this. So you can see here, he adheres to the green as much as possible. You can see that little blue line is the line that he's expecting to take to get out to the runway. So we put a large amount of work into making sure that the plane slows down around corners, that they turn correctly, that they do all the things that they need to do to get where they're trying to go in a realistic way. Because again, keep in mind, none of this is being done by the sim. This is all being done by us. So we're completely recreating how airplanes work, how they fly, how they move. This is BeyondATC's custom injector in every sense. So one airplane's cool. You can tell it's working. But where the real heavy lifting comes in is how to sequence many airplanes, right? For example, when you have a conflict, you have lots of airplanes all trying to leave at once. Who gets the right of way? How do you yield to each other? So let's go ahead and spawn 20 airplanes. They'll slowly come in over time as I spawn them in. And we can watch the system at work. So you can see already he's yielding to him, and as more planes start to come out, we'll start to get more conflicts. This was the hardest thing that we had to do and represented the most amount of time that we had to work on this problem. This is what I call the train track problem. If you think of a taxiway as a train track, only one airplane can occupy that train track going in opposite directions at a time. However, if they're going in the same direction, they're allowed to occupy the same train track, but they can't occupy the same space, aka they can't move on top of each other. So we had to create a system of switches and tracks that essentially say this plane is allowed to enter this segment at this time. In a game like Railroad Tycoon, the player is the one that's creating all the switches and tracks. So we know the data ahead of time in that situation, and we're able to very easily process it. But for this situation, we have no idea. The airport is just an arbitrary collection of points. So we have to evaluate the entire airport and figure out what's the most reasonable place to put the switches, put the tracks, and how to turn those switches back on and off, which requires a lot of high-level logic that's looking at the situation of the airport and saying this switch is green, this switch is red, and allowing this plane to move while this plane can't move. So this is a perfect example right here. The system also allows for airplanes that have been waiting a long time to start moving their priorities up higher. So if another airplane is coming down here and has reserved this entire segment, the airplane that's waiting here can push himself in a higher reservation point and move himself in front of that airplane so he's allowed to leave sooner. So now you can see he's leaving, and he will soon follow after. We have the same situation happening over here. And I just spawned many airplanes, all leaving at once, so this probably represents something more than any realistic airport will ever see. But the system needs to work no matter how much we throw at it. And as you can see, it's working beautifully. Everything is waiting on everything else, nothing's intersecting each other, they're all nicely queued, and they all have order. So we can go ahead and spawn some incoming aircraft now and make things even more complicated for the system. So now we have this airplane that just landed. Obviously it's not realistic that they landed right next to each other, but this is just for testing purposes, so just bear with me while I explain this. So these airplanes now are going to try and avoid the green paths. And if we look over here, this gives us these really cool paths where we have the outgoing airplanes taking this path, and we have the incoming airplanes, they step aside over here, and they go around the outgoing path to try and take an incoming path. The same thing as this plane. You see he joins up with the incoming path right here. So they'll do that and get themselves all the way to their gates. All the while the outgoing airplanes are taking a different path to get themselves to the runway. This creates some really realistic airport interactions where you have a lot of incoming airplanes and outgoing airplanes all working at the same time in synchronicity and not running into each other, avoiding each other, yielding to each other, and waiting for each other's turn. You'll see that he slow down around the corner, and then once they get to the straightaway, they can speed up to 30 knots. Meanwhile, these ones are all departing and staying in line in a perfect sequence. Alright, let's get to the good stuff. So I'll go ahead and load KLAX. And again, this is coming from the sim. So if I go back over to Microsoft Flight Simulator, what I'm seeing here is an exact mirror of what I see in BeyondATC. This translates directly into this. So let's go ahead and load an aircraft. So I spawned him in. And now, if I go back to Flight Sim, there he is. Now this is a one-to-one representation of what we're seeing from BeyondATC into the sim. How cool is that? Alright, but that's just one airplane. Y'all want to see 40. Y'all want to see 50. Let's do it. So I'll load in 40 aircraft. They'll slowly trickle in over time. And now, if I switch back over here, we can see them. We'll wait for them to all get spawned in. And I can show you that the simulation can hold up to almost any number of aircraft that you throw at it. Now here's the thing I really want to draw attention to. I put the FPS counter up here. 84 FPS, hovering around 90. I'll go ahead and look at the entire airport so you know it's not a fluke. So there's all the airplanes we were just looking at. (93 FPS). How cool is that? I've been hypnotized by this before. I can just sit and plane spot these things all day. So right now, they don't have any animations or anything, but this is the easy part. Adding the animations, adding the sound, that's nothing compared to getting the things to actually move properly, to actually get the simulator to recognize what BeyondATC is asking it to do. So that's our next step. We'll get all that working, but this was the hard part. And the fact that this is working so seamlessly and so flawlessly is a huge milestone for us. You still see it's still holding strong at around 85 to 90 FPS. And keep in mind, I'm running a debug environment, so this isn't even the optimized version. This is just the very first version that we got working. So I have no doubt that as we continue to work on this, it'll get even better. Now, how are we doing this? What is causing the FPS to be so much higher than the other traffic injectors? That's because the other traffic injectors take a very different method when they're injecting traffic. What they say is they say to Microsoft Flight Simulator, spawn the airplane here, and I want to send it over to here, and here's all the waypoints I want it to use. Then it takes the aircraft and it hands it off to MS, and MS then, that's the one that runs it. It's the one doing the calculations on how to get them from A to B. The injector can do some interesting stuff to try and change the directionality of how they're all working. It can say, oh, I want you to take this waypoint or take this waypoint, but ultimately, Microsoft Flight Simulator is the one choosing where the airplanes are at any given moment. That's not the path that we took. We're directly controlling the traffic because we have this 3D engine that we're essentially tackling this like a video game. We built all these systems to tell these aircraft where to be at any given moment. And we're sending Microsoft Flight Simulator the directions on where to put these aircraft per position. So every single spot that they're at, we're telling it every single frame to match the positions from BeyondATC. That means that Microsoft is doing none of the calculations. That means that Flight Sim is doing absolutely nothing under the hood to determine how these aircraft function, how they work, how they spawn, how they move, all of this stuff. It's just following the orders of BeyondATC of to where to put these things. The calculation of doing that when you hand it off to Microsoft Flight Simulator is incredibly expensive. We're bypassing that entire step, and that's what's allowing us to get the 90 FPS that we're getting right here. So after these initial tests, I'm starting to feel very confident in saying that not only can BATC be one of the best ATC sims on the market, it can also be one of the best traffic injectors on the market. And I'm very happy it's going to be able to do both, because what that means is you're going to get the full ATC experience top to bottom. You'll hear all of these aircraft give callouts. You'll hear ground telling them to hold short. Since we know what all these aircraft are doing, we know where they're trying to go, we know what they're thinking at any given moment, we know all the context around how to do callouts for them. So that means that we can have this one follow company out on taxiway Bravo or whatever, right? It gives us a lot of really cool options and versatility to be able to add really cool ATC callouts and interactions between the airplanes. And because the player airplane is just one of these airplanes in the system, right now the system is looking at our airplane, which is sitting over here, as one of these many traffic airplanes. It doesn't know the difference between them. So it's going to do callouts to the player exactly as it would do callouts to them, which means that if you're stuck in a line, it's not going to prioritize you. Maybe that's for better or worse, but we'll get all that ironed out, I'm sure. But it should provide the most realistic experience possible. Because again, it's not giving you, the player, priority. You're just one of these airplanes, and our system doesn't know the difference. So obviously here they're just despawning when they get to the runway. The next step is going to be to get them to take off and enter the airways and then communicate with each other and pass each other off to the different frequencies. But honestly, this was the hard part. This represents the hardest thing that we had to do, is how to sequence all these different airplanes on the ground, how to make sure they don't run into each other, how to make sure they follow the direct paths and everything. Once they're in the air, the air is a lot more wide open than the ground, and so that should be much easier to sequence the airplanes. I'm just not worried about that one compared to this one. That's why we started with this one, is because it's so challenging. So to me, this represents an absolutely massive milestone in the BeyondATC progress, and I couldn't be more excited to share this with you. So I'll leave it off here, but I really hope you enjoyed looking at this preview of our very first traffic injection into the sim. This will work at any airport, this will work on any airplane, so we should be able to get this into a really good state, and I'm very, very excited. Thanks for checking out the video, thanks for coming along, and if you'd like to follow the progress of BeyondATC, please hop into our Discord, link in the description below, and until next time, I will see you.